Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics in the chapters of mechanical actions and equilibrium of a body. This exercise was a previous one in the brevet exams in 2014 first session, third exercise. The title of this exercise is Stiffness of Spring. The object of this exercise is to determine the stiffness K of an elastic spring R. R is suspended vertically with its upper end O fixed to a horizontal support, so this is the support. Its lower end A carries a solid S of center of gravity G and of mass M is equal to 0.5 kilograms. So the mass of this solid is given by M is equal to 0.5 kilograms. The solid S is then submitted to two forces, its weight W and the tension T of the spring R. At equilibrium, the elongation of the spring is given by X is equal to 10 centimeters. Knowing that centimeter is not the SI unit of length, in order to convert from centimeter to meters, we simply divide by 100. Then 10 divided by 100. Then X is equal to 0.1 meters. And we have that G is given by 10 newtons per kilogram. Now in number 1, they are telling me indicate for each of these forces if it's a contact force or force acting at a distance. The force is the weight W and the tension T. We know that the only forces that are action at a distance are given by the weight electric and the magnetic. Therefore, the weight W is classified as an action at a distance. And all other forces are classified as a contact force, and in particular the tension T. Then the tension T is given by a contact force. Now in number 2 they are telling me indicate the point of application, the line of action and the direction of the weight W. So let's start by the point of application. Now, because the force, the weight W is given by action at a distance, then the point of application will be the center of gravity G. Now, as for the line of action, we know that the weight W always act on a solid S vertically downward, so the line of action is vertical. And the direction is given by downward. Then here just a side remark, so whenever we are listing the properties of a particular force, we need to list them in this order, starting from the point of application, the line of action, then direction, then the magnitude. Now in number 3, they are telling me to calculate the magnitude W of the weight W, knowing that we have the mass and we have the value of a G. Then the weight is given by M times G. The value of M is given by 0.5. And the value of G is equal to 10. Plugging this on the calculator, it will give me 5. Since both M and G are in the SI, so the value of W will be in the SI, which is in Newton. Then the value of the weight is given by 5 in Newtons. And now in number 4, they are telling us show that the magnitude of the tension T vector is T is equal to 5 newtons, knowing that in part 3 we have already calculated the magnitude W of the weight W and it's given by 5 newtons, and the solid S being at equilibrium, then we can make use of this condition. Then let's write down at equilibrium. Then how do we apply this condition? Always on the left we'll write the sum of forces acting on S, and they are given by the weight W plus the tension T. And on the other side of this equation, we will write the zero vector corresponding for the condition of equilibrium. Now moving T to the right hand side, then the condition of equilibrium will be given by W vector is equal to minus T vector. So the first equation tells us that, so this is the first equation, tells us that both W vector and T vector act on the solid S to cancel each other, whereas the second equation tells us that both W vector and T vector have the same line of action, opposite direction, and same magnitude. Since we are interested in calculating the magnitude of the tension T, then let's say in magnitude, that the weight is equal to the tension, but knowing that the value of the weight is given by 5 newtons, which means then the tension T is equal to 5 newtons as well. So this is it for part 4. Now in part 5 they are telling me to determine K, in which K represent the stiffness of the elastic spring R, and K can be determined by applying Hooke's law to the spring R. Then let's say apply Hooke's law. And Hooke's law is given by T is equal to Kx, in which x represents the elongation of the spring. Now let's construct the triangle of this formula. Here, since we have multiplied and T will be at the top, K and x are at the bottom, and we are interested in calculating the value of K, then the stiffness K is given by the tension T divided by the elongation x, and the value of T is given by 5, and the value of x is given by 0.1. Now plugging this on the calculator, it will give me 50. Since both T and x are in the SI, so the value of K will be in the SI, which is a Newton per meter. Then the value of K is given by 50 newtons per meter. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.